So today what we're going to talk about is creating section views, and why do we create section views and how do we create section views. Like I mentioned, this is from chapter 9, so I'll go through a few slides here from chapter 9. And the idea of a section view is, again, we're just cutting a part of the part out of the way so we can see what's inside of it. And sometimes that's just so that we can describe it better. Other times it's because we need to dimension something. And you might remember one of our rules of dimensioning is that we do not dimension to hidden features. So if I've got some sort of feature inside of a part, I need to create a section so I can see what's inside there and then properly call it out. So as an example, here's a part, the top view. You can see that we've got the section line cutting through here to show us where the cut is taken. And then anywhere there is cut material, we show the section lines to indicate the material. And then, of course, anything that's not cut material is just left as it normally is. So the back of this opening, for example, is what's shown right here. So again, the idea is we've got an imaginary cutting plane and we draw it with a phantom line type and some arrowheads. And the arrowheads point in the direction that we're viewing. So again, if you look at these arrows here, we're basically saying that we're cutting out this portion and then we're looking that way to see what's left. And that's where we get that view from. And as I mentioned, only the material that's actually being cut is going to show that section material, or the hatching, if you will. And any hidden lines that might be in the part, we do not show unless there's a special reason. I don't really run into too many special reasons, so typically as a rule, we don't show hidden lines inside of a section view. So for example, this edge back here would make a hidden line in this view, but we don't show it in a section. So again, just to call a few of those things out, cutting plane, we've got our hatching lines, surfaces beyond the plane. Now in terms of different types of sections, we have a full section, which means we cut all the way across the part. And that's what we're going to do today. So that is an example of a full section since we're cutting all the way through. Half section, we only cut halfway into the part. And by halfway, sometimes this is kind of confusing, but with a full section, you're literally cutting half the part out. And then with a half section, you're basically taking a quarter chunk out. But if you think in terms of what the resulting section view looks like, either the full thing is sectioned or only half of it is sectioned. We also have offset sections. We'll talk more about these in the next couple of days, but here I've got some features that I want to call out that aren't in a straight line, so we can create an offset section. We can also do revolved sectioning, where we show the section pieces in place. And then a removed section, which is kind of similar except we pull the pieces out. Again, we'll do these in the next few days. And a broken out, where we just kind of cut out a chunk of the part instead of half or the whole part. So there's an example of cutting out just a chunk. And then when we get into some more complex parts and assemblies, there's certain things that we don't section, such as holes is pretty obvious, but ribs and in assemblies, pins and connectors and fasteners and things like that. Again, rotated revolve stuff we'll come back to in the next couple days. The section lines themselves, the spacing, we will basically want to match our scale of our drawing. So if we've got a 1-to-1 view, then we're going to use a scale of 1 for our hatching. If we're going to print it 2-to-1 or 1-to-2, then we're going to adjust our scaling either to 2 or 0.5 depending on the case. And then the angles are typically 45 degrees. That will be done automatically for you. When we get into assemblies and we have adjacent parts, then we'll alternate them. So here you can see a few different patterns. The patterns also indicate material. So double line often means steel. We'll see some of that referenced, but we'll mostly be using just the ANSI 31 angled line patterns. So this is a shot from AutoCAD of the different types that we can use. We'll look at that here in just a second. Started mentioning this on assemblies about not sectioning everything. We'll come back to that when we do some assembly stuff. So I want to just show you a few things in AutoCAD then. So if I've got a part in AutoCAD and I want to section it, the first big thing that you need to do is make sure that you put the hatching layer current. And if I look at the layer properties, the hatching has a thinner line type than the object, and that's how we want it to show up when we print. We want it to be clear what's an object line and what's a hatching line. Don't use the section lines layer, because the section lines layer is actually, let me make a little shape here. So let's do something like that. Set that back to an object real quick. Let's just say that I've got a circular feature in here. And then I'm going to project that down to create my front view. Okay, and I'd have my center line in there too, but in the interest of time, I'll keep going. So if this was my front view, these would be hidden. Check how big a thing I drew here. A lot bigger than I meant to. Scale this down real quick. Okay, that's better. So this would be my top view, this would be my front view. The lines are hidden. The section lines layer is actually my phantom line. So if I wanted to create my arrows cutting through here, this is where you're going to get the phantom layer type. And then to draw the arrows, you've got a couple different things that you could do. You could, literally draw them in with some lines here if you want. Maybe mirror. Oops. And then fill that in maybe with a hatching. You could also just simply create a dimension and then explode it. And then erase everything except for the arrowhead, and then you can reuse that arrowhead. That way it's actually scaled properly too. So I'd recommend that instead of fooling around trying to draw one. Just bring in a dimension, explode it, and copy it. So there's my section line showing me where the cut is. These would now be visible lines. And then when it comes to hatching, again, I'm going to make sure the hatching layer is current. And then I'm going to use my hatching tool. And here's all the different patterns. Like I said, we'll mostly be using ANSI 31, which is kind of a general use one, but you can see there's some other materials down below, such as steel. There's architectural ones in here as well. But for this one, you just got to click in the area that you want to hatch. So I'll just simply click in these areas and hit enter. You can see that if I select the hatch, here's the scaling up top, as well as the angle. So today's exercises, for example, are going to be 1 to 1. So you won't do any scaling on the hatching. If I wanted a 1 to 2 viewport, then I would want to go and adjust the spacing of my hatching so that they're not so close together. So I'm going to go and give it a factor of 2. So that way the space between them is consistent. But like I said, today they're both 1 to 1, so you'll just leave it at a scale of 1. So the plan for today then, a couple of drawings out of chapter 9. On page 250, we have 2 parts. Taking a look at the first one, this 9-35 shaft base here. You are going to draw a front view and a top view of this part. The front view you're going to turn into a section view. So your top view will have your section arrows cutting across, much like you see here, right through the middle. And then your front view you'll turn into a section view. And if we look at the instructions up top for 935, it says that surfaces with that texture symbol is going to have a texture rating of 125 microinches. And they also give it to you in metric because they're referring to 2 different parts. One's a metric and one's English. So don't be confused by that. So you're just going to use 125 and then machining allowance of 0.06. And then the other thing that I want to point out to you is a question that I get a lot, and that is when you have a hole, if you're not given a depth, that means it goes all the way through. So for example, Diameter 0.5, 2 holes. It goes all the way through since you're not told otherwise. But we also have some counterboard holes, or spot faces actually it looks like. Similar idea. So diameter 0.34 that goes all the way through, and then a spot face of 0.7. And remember, we on an English unit drawing we can just go down a 1/16 of an inch, or 0.0625, just enough to cut through there. So when you're creating the section view, these guys back here would be hidden, but we don't show hidden lines, so you won't show those at all. You really just be showing these two in your section view, as well as the inner ones, of course. And as always, don't forget your notes. And don't forget to actually do the rounds too. So the second one you're going to do is over here, 937. And this is broken out right here strictly so that you can see there's a hole there. So you won't break that out on your drawing or anything like that. Just need to be able to see that there was a hole there. This one, again, same idea. You've got some notes over here for 937 and what the roughness is, 63 microinches, and then the machining allowance of 0.06. You're going to have to draw a front and a right side and a top view to get all the geometry shown on this one. So 3 views on this one. And then you are to turn your front view into a full section. So cut it completely in half and show what it looks like cut through there. Then on top of that, you've got some fit values here. So this one has a hole with a diameter of 0.76 that has an RC6 fit. So again, we know on holes that this value is the lower number. So 0.7600, go look it up and see what the hole tolerance is to find the upper value. And then again, your counterbore and your depth, same thing here. So this one cuts all the way through, so there's not a counterbore and there's not a depth, but you're going to look that up as well and show them as limits like we've been doing. And then you can see several different texture symbols down there. Actually, let me show you one thing real quick on dimension styles. So let's talk about this little area down here. There's a lot of stuff, and I'm just going to emulate that in no particular size, but I'm going to create some lines here to work with. And then, so let's say I want to put my surface texture symbol on all 3 surfaces, and I'm going to do that with leaders because I think that's probably the easiest thing to do. So I'm going to switch back to dimensions. I'll draw my line. I'll draw in the little symbol here, of course. But I want to show you the leaders. When I go to put the leaders in, and again, remember that we want to avoid a very horizontal or very vertical leader. And so I'll snap there and just enter instead of putting in, or just click away from it, excuse me, instead of putting in text. But if I want to point to some of these other areas, if I do another leader, maybe from here, that one's not so bad. If I do one, over here, it could be a better leader. It could point to that surface a little better, whether it's coming out this way or another direction. So I want to show you how to do that. You can go to your leader style. So if I click my annotation drop down and go to my leader style here, and then modify my leader style, on the leader structure tab, there is a maximum number of leader points. This is why I click here and I click here and all of a sudden it goes to the text. I can clear that check and I can make as many vertices as I want. So for another leader then, I might decide I want it to point out this way and then come over here. And the key is you just press enter when you're ready to get to the text box, and then you can click away from it. So even if I maybe wanted to have this point a little better at this one, I can maybe do something along those lines. That's awfully vertical though, don't like that, so I might adjust that a little bit. So feel free to go in and turn that off on the dimension style so you can get some nicer leaders that aren't, pointing oddly at the shapes. And if you need help getting that changed, just holler at me and I'll help you do that. In fact, we could change that in a template so that you don't have to worry about that in the future. Does that make sense? All right. So those two drawings, I got the slide up here. I'll pop them on 1-to-1, and I'll let you decide B size or C size. So draw the models and see how they fit. The second one, since you're doing 3 views, maybe it's going to fit better on a C size. That's up to you guys. Still got to do all your dimensioning in addition to the new ones. So let me know as you run into any questions.